All right, number 25, we have h equal to negative 4.9 t squared plus 25t. The equation above expresses the approximate height h in meters of a ball t-second after it is launched vertically upward from the ground with an initial velocity of 25 meters per second. After approximately how many seconds will the ball hit the ground? Okay, so this question is what I call a quadratic modeling. Okay, so we're trying to use this equation. This is a quadratic equation because we have a t squared there. This models the movement of the ball. Okay, so if we kind of think about the graph of this equation, right, we don't have to graph it accurately, but the overall shape of this graph should be a parabola opening downward, right? Because it's a quadratic, so we know it's a parabola, it's like a U-shaped graph. And open downward is a negative a value. Okay, so it'd be like that. And then it makes sense, right? So you think about the path of the ball, right? It goes up first and then it comes back down because we have gravity on Earth, so it pulls it back down. Okay, so the x value here is like the horizontal axis. So x value represents the amount of time, right? And then the y value, if I label this the y-axis, that's like the height in this case. So that'd be like h. Okay. So what happens is the question says after approximately how many seconds will the ball hit the ground? Okay. So we have to know what are we solving for here. Okay, so when the ball hit the ground, right, at that point, the h value, right, the height should equal to 0. Right, the height should equal to 0 because the ball is on the ground, right? So it's on the ground, so there's no height. Okay, so the height should equal to 0. And that's what we want to do here, right? We want to set the h value equal to 0 because it's on the ground, so height should be 0. And we're trying to solve for t. Okay, we want to know what time will make the h value equal to 0. Okay, so that's what we can do. So graphically speaking, these are the x-intercepts on the graph. Okay, so when y equal to 0, we're solving for the x-intercepts. Okay, so let's go ahead and plug in the h value equals 0. So we 0 equal to negative 4.9 t squared plus 25t. Okay, so we're solving for a t value that will make this equation equal to 0. So we can either solve it algebraically, but we can definitely plug in answers, right? So since a multiple choice question, we can definitely use the answer choices to help us. So if you go ahead and try each one and plug it in and see which one works equal to 0, right? Then whichever one worked, that'll be our answer. Okay, but let me work out this algebraically so we can see the step. Okay, so if we're solving this algebraically, we can actually, since it's a quadratic equation, I only have 2 terms, it's a binomial. So we can check for any common factors. Right? If you check the 2 term, we can actually factor out a t first, because that's a common factor for both terms. So we pull out a t in front. From both terms, we should have t times negative 4.9. And then, so negative 4.9 t squared. So we divide out t, we get negative 4.9 t right there. And then plus 25t, so we divide out t, we get plus 25 like that. All right. So that would be the factor. So after we factored it and set it equals 0, then to solve for t, and so we can set each factor equal to 0 and solve it. So the first one is just t equal to 0. The second factor, we set it equal to 0. So this is called the 0 product property. Okay, once we factored it, we set each factor equal to 0 and solve. So we get negative 4.9t equal to plus 25 equals 0. Okay, so to solve for t, we do minus 25. We get negative 4.9t equal to negative 25. And solve for t divided by negative 4.9 on both sides. We get approximately 5.1, right? So T is approximately positive 5.1. Okay, so the closest one, right, or the approximation. So it had to be either 0 or 5.1, but here they're looking for the time when the ball hit the ground again. Okay, so we're talking about this number, so it should be 5.1. Okay, the closest one will be 5 seconds. Okay, so D will be our final answer for this one. And if you look at these two are the x-intercept, right? So at t time equal to 0, time equal to 5.1, the height is equal to 0, so that the ball is on the ground. All right, so D is our answer for 25.